A very happy evening to all the teachers who are present here, and I welcome you all to the final session of Outreach Teachers Program 2021. It gives me great pleasure to have been part of this journey wherein SSERD has taken the initiative to help all the science educators out there to innovate in the educating system techniques that we have right now. For the past 3 days, we had different guest speakers from Ayuka and Maulana Azad National Urdu University, that is Priya Ma'am and Shivani and Atharva, talking about various techniques that could be adopted during teaching. We started with neuro-linguistic programming, then we went on to look at how to plan an event and about on-spot activities and various initiatives that are taken by various NGOs out there to take science communication, science education in an innovative manner to students. So today we have a workshop by SSERD wherein we'll be talking about a program, a science space education program that can be organized by teachers in their very own school. To do this workshop, I invite Ms. Nikita C., co-founder and CEO of SSERD. It gives me great pleasure to have you with us today, Nikita. So I let you take over the screen.
Thank you very much, Tejas, and to everyone who's watching, all those teachers, educators. This program is planned and executed in such a way that it helps you understand how important space education is, and the outreach part of it. Um, we've always been reaching out to students, and this is the first time we thought we should reach out to teachers to create that impact in a larger way on all the students. So you've been taking part in various programs that has been happening in this week, and this particular day is going to be a special day because we are going to do some activities. We're going to teach you a few things that you can directly go and teach at your institutions and schools. It is designed in such a way that we will give you the slides as well after the whole session, where you can take the exact same content and teach to your students. We would be very happy to see you all go teach this at your schools, or if you are an educator, you can go back to your school and or the community around you, take the sessions and send us some information telling how your audience liked it, and send some pictures. That would be great, and we would continue to do this from now onwards. Now, to go ahead with today's session, wherein, as I said, this particular session, you can consider it to be something where you can exactly go and do it or teach it in your schools or the community. I'm going to share my screen, which will help you understand few things which I would speak. Yeah. Tejas, can you help me to know if it's visible
Yes,
to
Nikita,
everyone?
we are good to go.
Great. So today's, or you can call this whole program for your students as workshop on charting the night sky. I'd like to say that this program could be done both online and offline mode. There are few certain things that could be done online, like how we're talking, you could also teach it online. There are some activities which could be again taught online if you tell all of them to bring certain materials. At the same time, you could also conduct this in a offline way as well. But it would be very nice if it is offline, with many students coming and asking and getting their doubts cleared, having their hands-on education. But yes, as I said, this can go as both online and offline. And then there's few activities which could be again done online and offline. So to begin with, uh, we would always let you all tell or begin the session by creating that curiosity among the students, creating that interest among the students about this whole space and astronomy, because we are talking to students, and the only way to make them stay with us throughout is to make them get interested about it, right? So we start with telling them about the night sky. This is something which is going to be very, very interesting for them, because you can tell them, okay, after this whole session, we want you to go and observe in the night sky and tell us what you found, right? So this way, it's a very good way to start. We have tried this out like many a time, and this will help very well, I can assure you on that. So let's go back to what we are supposed to talk, right? So I would like to tell you all, follow this storyline, and that's what exactly we do at SSERD. We tell them, have you seen the night sky, and what do you see? Of course, the answer would be stars. We tell them, okay, look at these stars, and can you make some pattern out of it? Every student would come up with a different pattern, and that's what the beauty is. That's exactly what happened long back, right? All our ancestors used to look at the sky and they used to imagine of something. They'd be like, okay, this looks like this. These connecting four dots looks like this, right? You can see examples over here. Like you compare these things to something which is in real and give them a name. And exactly what happened long back, which we're gonna make our students understand how these constellations got their shapes or got their name. It's just by imagination. So take them to that world of imagination with the help of these patterns in the night sky. You can also give them some make give them few stars. Like there's two way you can make them get interested. It's like the very beginning activity. You can give them set of like a sheet of paper and probably few stars. We can easily buy these stickers, right? So we can buy these stickers and give them a sheet and ask them to make some pattern with the help of these stars. Or you teach them about few patterns and then ask them to create those patterns on that, right? A lot of activities could be done with just this stickers, or you can give them some stars, or even by drawing could be done. Going further, what do we have, or why is it so important, or what all can we talk in these patterns of night sky, right? So let me just give you an example. This is a picture of a night sky, and we can ask students, okay, what can you observe here, like as I said. And I would also request all the teachers here who's watching this, all the educators out there who are watching this, I'm pretty sure you would have already identified which constellation this is. If you all know it, start putting it in the chat. Let's see who gets it, because this is a very easily identifiable constellation, and it is there most of the time in our sky. I can give you a hint. You can see there are three stars continuously, like with very short distance between them. So yeah, I meant these stars, not these three stars, but these three stars which are like in this. Okay, I'll give you a few more hints. So if you can look at this, you will see these are the stars. Okay, we have Betelgeuse, Bellatrix, Rigel, and then there are three stars. These stars have name of these: Intaka, Alinan, Nilim, and Alnitak. Um, like the name would have given you some pattern by now. Okay, I'll tell you all what it forms, or you can find it by yourself. So if you connect these stars like this, you saw it got a certain shape, and this is called as Orion constellation. We call it as a hunter, because when they connected these stars long back, they felt like there's a body, there's a belt, and then it also represents like two hands wherein one hand has an arrow kind of object, and another hand has something to protect themselves, just like soldiers or hunters and things, right? We can use, this looks like a bow and arrow, and that's why it has got a name hunter, right? And this is called Orion constellation. It is mostly visible in the sky. Whenever it appears for like 3 months and twice in a year. One of the wonderful constellations that you can ask all the students to see and identify in the sky. You All you need to do is they just need to find these three stars and locate this whole constellation. And it's also called as Orion belt. Okay. As I said, there are a lot of other constellations which could be easily found in the sky, but you need a observe, like you have to observe a little bit, right? So like constellations like Ursa Major, or we can also pronounce it as Ursa Major, Ursa Minor, and the Pole Star. Pole Star is so important, right? Which we can tell all the students that this is something which is used for directions, because Pole Star doesn't move. It doesn't look like it moves. And long back, we used to use that for navigation. We can tell this point so well that the students will understand. Today, if we have to know what direction we are going in, we can use compass and phones and everything. But imagine long back when there was no such technologies, what do people used to do for navigation if they want to go to certain place? They used to use stars and constellations as navigational tools. In the morning, you have sun, so you can use it. What happens in the night? We use stars and constellations. And Polaris, or this polar star, is something which is fixed in the northern hemisphere, like, and you use that as a point. Okay, if you're going towards it, then you're going towards north. If you're going away from it, then it's towards the south, right? So such way we can find the direction. If you know where is Polaris, which is most of the time like brightest star, you can find this Ursa Major and Ursa Minor just around them. All right. Now going further, as I said, the Polaris is a North Star, and you can also find these are few other constellations which should be just there: Minor and Canis Major. We call it as Big Dog or Little Dog. I'm not sure how they imagine these stars to be looking like dogs, but pretty sure most of them would have agreed at that point of time. You might ask a question: are we supposed to just think that these are the only constellations, or should we just consider these to be the only constellations, or we can't give it other shape, or we can't give it other name? um, the answer is you can form your own pattern in the sky, right? Like we all must have observed sometime, when it's cloudy, you will see some clouds having certain definite shapes which would resemble to things like it might look like a dog, it might look like a basket, sometimes it looks like shoe, or it's just our imagination, right? And that's what happens here. So you let students imagine and create those patterns, but from the standard point of view, we have around 88 constellations that's identified and it's noted, and we follow them. Apart from that, you might form your own and that would just be yours, but it's good to look into other various stars and identify those constellations which are already there. Now, use of stars in navigation, as I said, the importance of it. Long back, if they had to travel in water, right? Mostly on the roads, it's easy, but on the water, because you don't have any point of consideration, right? When you're going in boat, you need to know the direction. So we usually used to use stars for the navigation. Like you can see the chart in his hand. So keep following this star like that. And the constellations also. So people would have traveled so much in the water that time. They know, okay, if you're traveling this way, the constellation would look like this in so and so direction, keep observing for it, and then keep going. At the same time the distance, right? Like, okay, if this is this far, then you are getting closer, something like that. So all these stars and constellations were used as one of the navigational tools, which would be really interesting for students to think about it and work on it. Now, we as teachers, what can we do with this thing? You can ask them to find one of the brightest star and ask them to find the direction of it. And if you want to organize some offline event, and if you choose to do it in the night time, I think we can conduct a lot of fun activities. Tell them, okay, you point one, like you look for a very open place and tell them, okay, now tell me which star is it, or which direction is it in. All those things, it would be really nice. We can do much more activities, which I'm going to share like in some time, but it's wonderful, right? Now, a brilliant bright dots in the sky, they wonder which among them is mine. I begin to wonder. So this is a quote. It's a very beautiful quote, right? Like, let them think which is theirs, and everything. Now, coming to that point of the star chart. Actually, star chart has been something which is favorite for students, that we have seen among the students here at SSERD, right? Because it can help students to see, okay, which star is when is it going to come, on what day, what time, which constellation would come, which planets would be visible. So knowing about the star chart, making one and making them do one is going to be another wonderful activity. All right. Like, basically star chart is a diagram showing the relative position of stars. Like, let's say this star is in this, and then these are the constellations which are there, and these stars will change from place to place as well, right? Like, if you all are in Bangalore, and if you're looking at from Chennai also, there might not be that much of difference. But if you're looking at particular particular sky from India, and if you want to look at that from Singapore, it might be little different. At the same time, different countries with different time zones, right? Or different altitudes and attitudes. So star chart will change from location to location, as in from, because it's our point of observation where we are standing right now. Things will change, right? At the same time, they're also moving, we're also moving. So this star chart are, like, I can say, very dynamic, and also not that much limited to one, just like the whole world. It changes. But it's one of the wonderful activity. As I said, it will have the direction, you can see north, south, east, west. And then it will show the horizon where the planets would come in, right? And which are the other constellations which are in line, which are going to come, and all that. In fact, this star chart is like a hard copy, right? You can give them some sheets. What we can do is, after this whole session, we can send out to you the hard copies, or like the soft copy, which you can take a print out and cut it and make your own star chart, and ask the students to do it as well. So this star chart, you can cut it in the shape, and you can rotate it to see, okay, which day, which exact time, and everything. At the same time, if you want to do the same activity in an online way, then there is an app called Stellarium. I will let you understand what is that in some time. But Stellarium is something which will help everyone understand the star chart in a better way. All right. Going further, development of star charts for navigation. Like, how did they develop? I always wonder how those were made, right? In fact, I also today wonder how our normal land maps are made, because it shows every street, every road, at the same time everything that is there around, how much time one would have spent in exploring that place and making such chart, right? Though the place keeps changing every single day, some new road, or they would have closed a road, or they would have built something, they would have closed one lake, or they would have dig up a new lake, or new So this keeps changing, but most of the things would remain same. Now look at the sky, right? Compared to earth and sky, I see this nothing much changes could happen in the sky, and that's why we've been using this from hundreds of years. It's not like just 100 year back, it's, I can say, the thousands of years back, because these stars have been appearing, and then because it's all the motion, right? Like the earth goes around the sun, and when it is going around the sun, it has to see certain path. At the same time, while it is rotating in its own axis, again it gets to see certain constellations. So these things remain same, just that we got to know what day, what time, and from where you're looking at. And these stars would tell us what are the different constellations that are there. And most of the time, which constellations come one beside the other. Like finding out, if you can find out Orion constellation, then it will help you to find what is the next constellation, because there would have been connection from this star. These many, these many distance ahead, you'll find this so and so star. Like for example, you can see this Polaris. Polaris is something that you consider. From there, you'll count like one. Usually, it's like, okay, continuously there are four stars, and then there are four stars forming that square shape. Not exact square shape, but kind of like, uh, a shape which is like a spoon or a kite, right? So you will easily know, okay, this is one of the constellation. And from here you go little forward. For example, from Polaris, you go left in this straight way, then you'll find another four stars, which gives you our Major. And then you have Ursa Minor, and then you'll see another constellation here, another constellation here. So you just take one brightest thing or one particular star, then you can actually navigate all of them. So basically, you might ask a question, okay, apart from these stars and constellations, what else can we see in the night sky? We can see moon, as we all know. We can see meteors. If we are lucky, we can also see meteor shower at particular set of time. We can see satellites. You can see a satellite moving so fast in the sky. It will appear only for some few seconds actually, but it will be wonderful. We can also see planets, and these are the things which you can see through your naked eye. You don't need any telescope or any instrument as such. But if you want to see in a magnified way, then you would need a telescope. Like planets, I can easily say, okay, this particular planet is Venus, because I know it. But what about those students who don't know? I'm pretty sure even you would have you would have sometime found, "Wait, why is this star like so bright?" Right? We would have experienced that. Now, what is the difference between a star and a planet? I think this is one of the important information that you can share with all your students. Like, ask them the difference between, okay, how do you find a star and a planet in the sky? If any one of you here know, you can comment as well. That would be great. But basically, you go look into the night sky, and you'll see most of the stars twinkling, or all the stars twinkling. But then you will find something that are not twinkling. Most of the time, planets are the one which will not twinkle. All right. So this is one way that you can identify. Venus is seen very bright. Mars is red. Again, you can see it very well. Jupiter is like little bright, but smaller than Venus. All right. Like when you see through naked eye. And most of the time, Jupiter and Saturn are they come up, they appear almost at the same time. They would be at some certain distance. Last year we had conjunctions of Jupiter and Saturn where they were very close to each other. So these are the special events where you can see the planets through your naked eye, but with telescope you can actually see how the exact surface is, the color and everything. Moon, the way you could see the moon with the help of the telescope, the kind of details that you can see through a telescope is wonderful, right? But yeah, the moon as well, different phases of moon is something that is beautifully, uh, we can show it so well. because our students, uh, I can say those students who would have learned the phases of the moon, it is easy for them. But for those who don't know what is phases of the moon, they'll be like, okay, this part of the moon is not there, where did it go? But through telescope we can show them the rest of the moon, which is still there, but it is darker region, right? Like only the lightened part you can show, whereas the darker region is still visible through our telescope. Whereas if we see through our naked eye, we all know that, right? We can see only crescent moon. Whereas if you want to see star clusters, nebula, galaxies, we would use these astronomical instruments, telescopes, and binoculars, which will let you see them very well. Trust me, very, very, very nice views that we can see with the help of these two. I wanted to add another point over here, that to see, there are a few things, like as I said, meteor shower, most of them ask, should we see through a telescope? The answer is no, because they would be traveling in so high speed. By the time you would have seen and you want to see through a telescope, that would have just passed by. So meteor shower are always good to see through naked eye, like they're just falling like shooting star, right? We all must have heard of shooting star. So meteors look like that, and it's always good to see through naked eye, because you might take much time to see through a telescope. And again, seeing through a telescope, you would just be limited to one place and you might not be able to see. Another beautiful thing to see in the sky, but you need to know when does it appear, is ISS, International Space Station. You all can go and search. There is something called live ISS location, or it will tell us. It will actually take where is our, like, our current location. Okay, and then it'll take our current location and it'll quickly map out when is ISS passing through our location, and it'll give like a table telling, okay, ISS is gonna pass on these days from this direction to this direction, which will appear for this time. So look at exactly these locations, and you can see they're just moving, and it'll not twinkle again. If you see through a telescope, you will see the ISS structure very well, right? So these are again like really wonderful things to see. I'm gonna quickly go to next set of things which you can teach and also learn at the same point of time. Certain things if you want to see. For example, here I said you can see moon, stars, constellations, and satellites and everything. Well, if you have to see certain or like if you want to see particular celestial object, you need to know something called coordinates. For example, we want to see particular nebula. Okay, you want to see particular nebula, you will only get the like you want to know its location, we get the coordinates. So you must be good in reading those coordinate and finding where it is, so that you can point your telescope in that way, right? So coordinate system is something that is like really, really important for you to know, to keep track of the objects in the sky, or also to convey the object of interest to other person. Like if you want to tell someone, okay, students, ISS is going to come today from north to south at this angle. Okay, I'm introducing you all to a new word like this angle, because you might ask students, okay, students, look at the north, right? They would look at the north, but usually the sky is up. You have to tell how high they have to see, right? So that's basically angles, which we will be exploring now. As I said, horizon and angle of elevation, which is very, 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 very important for the night sky observation. You all can do it along with me. At the same time, while you're teaching, you can also ask all your students to do it along with you. Now, one of the things that I would want all of you to know is horizon. Whatever you could see to your eye level, like you stand on your terrace, you can see probably like far away some buildings, or if you're in a very rural kind of place, I'm pretty sure you all can see like the farmlands, or if you're someone who's close to the water bodies, you can see the water touching the sky. So as much as possible, as far as possible, you see That's horizon to your vision level. Okay. Now you want to see a certain star which is at some certain angle, as I said, certain position in the sky, right? Now what you need to do is you need to know the angle. So this is something called this is an instrument which is holding to understand what angle is it in, all right? And this is the angle which you need to, like as I said, horizon will be like, like you can consider it to be 0 degree. And as and when you go higher and higher, you count 0 degree, from 0 degree to 1 degree, 2 degree, 3 degree, right? It goes up. And maximum 90 degree you can see, like right up. Okay. If you want to see back, you can either go 90 to 95 and or you can literally say from this direction, turn, like measure this way. So most of the time angle of elevation is 90 degree. So whatever wherever you would see, you will see 90 degrees, not more than that, because they would have mentioned from north 60 degree, right? You have to face north and measure that, 40 degree, 30 degree, and that's where your star would be. And if it's completely behind, then they would have represented this the opposite direction, and that 20 degree, right? I'm pretty sure all the teachers here know that, you add up or you subtract, you get the other way, right? So this is one of the important thing which we want all of you to know. Tell them that this is in degrees. Okay. At the same time, I told you directions becomes very important. The students must know north, east, south, west. In the mornings, it becomes easy with the reference of sun. You can tell them where is north, east. If they know east, then all the other three directions becomes easy. But in the night time, it is a little different. So it's good if you, like, give them an idea, or like start your event, or do this particular direction event when you can at least see the sun setting, so that you can ask students, okay students, tell me, where does the sun rise? East. But where is the sun right now? It's in the west. So they know east and west, the rest two directions they can easily find it out. But as soon as the sun sets, you can't actually make out where was the sun unless you are in that place. For example, if I'm at my home, I know where usually the sun rise, which direction it is, or where my which face, or like my house direction, my house is facing which direction. We all know it. But if you go to some place where you were not there, then directions becomes really, really important. So it becomes very important for you to tell them about the direction. So teach about the direction, teach about this angle and angle of elevation and horizon. These two will help us to observe all the things in the night sky. So these are the convention for the direction angles, as I already said. We have north, south, east, and west, right, this way. um, so you start with north always. You start from zero and then go ahead. So you can see this region is called as northeast, right? North, between north and east, it's northeast. Because sometimes it becomes easy for you. For example, like let's say there is a star over here, then you can't tell. It becomes easy for you to say, like 20 degrees to north northeast. So they know exactly there, north northeast, northeast east, east southeast, southeast south, south southeast. So these are the directions which we usually use to or refer, where they exactly know the angles directly, right? um, or you can, if you even if you just say northeast east or east northeast, then they know the angle is somewhere between 45 to 90 degree. Simple. They don't think much more. Okay. So if you can look at the second picture here, um, one thing that we have to know is, to look into any star or anything in this night sky, always start from facing the north. So you have to find your north. Once you find your north, you gotta know your azimuth, like across the direction. Like for example, just consider I'm facing north, I'm facing the camera right now, and that's my north. But I have my star which is somewhere there, like just somewhere there, right? Now what should I do? I have to always face my north and start from this way and turn towards this way, right? Like this is my angle, like I'm seeing like this, and I turn this way. This is my angle, all right, and that's called azimuth. So once I know I turn this angle, now I know my star is here, and this is angle of elevation. So these are the two angles which you need to know: azimuth and angle of elevation. All right, azimuth directly speaks about the directions. The terms to remember everyone: zenith, the point right overhead, like right there. Okay, then we have azimuth, which is horizontal angle measured clockwise from north. Always face north and go clockwise. Okay, it's, as I said, it's the horizontal plane. And then angle of elevation, or we can also call it as altitude, simply altitude, and that's basically measured from that point on up to until your celestial body. All right, but that's, again, as I said, it's always in the horizon. So use of angles to locate objects in the night sky, you need these two things. All right, so one is the azimuth, as I said, from north, how many angles, and once you got that angle, you have to look up now, right? That's the angle of elevation, or as I said, the altitude. So this is how we can most of the time observe the night sky. Even now, if I tell you, okay, teachers or students, you can tell this to students, right? Students, look at the sky 30 degrees from north and 40 degrees in the 40 degrees is the angle of elevation. The students will turn from north 30-degree, and from there they will raise up their head for 40 degrees to see so and so star. Right, these are the two things which you can use. And we have an activity right now to construct your own star chart, like in a really practical manner, which will help students to actually understand how does this work, or how to find errors also, and everything. Okay, for this I would call upon Tejas to take over. Once he finishes, we will go back to stellarium if we are still left with time, or we would give you the link where you can explore much more, and then we would proceed.
Thank you so much, Nikita, for that wonderful explanation. So here we come to the main part, wherein we'll be teaching you about the activity that could go along with this material and that can be executed right there in your schools and community. So can we advance to the next slide, please?
Yes.
So there are two things that are required for us to go ahead with this star chart activity, charting the stars in your own way. So first thing is a clinometer. We can make a simple clinometer at home. So we have a list of materials here. So we need a piece of cardboard that is cut in semicircle. Right now I have a cardboard with me, okay, and we need a length of a string, an object to hang as a weight, a long straw or a cardboard rolled out to form a tube. So I have another piece of cardboard with me. So I'll show you how to make that tube as well. And we need clay, scissors, and glue bottle. All right. So let's go ahead with the activity for making the clinometer. So first we have a piece of cardboard here. So what we have to do is we have to mark a semicircle here. Okay. So the width of this particular semicircle, it can be close to 18 to 20 centimeter, whichever is convenient to you. But remember that whatever the width that we will be using, it is the same thing that we'll be holding in our hand to view the object. So it is convenient that if we have the width of the semicircle, that is the diameter of the semicircle, close to 20 or 24 centimeter. Okay, I've already marked it. So I'll be cutting out a piece from it. It is also better that you have a protractor along with you for this activity for us to mark the angles. All right. So now I have a piece of semicircle with me right now. So I also have another piece of chart paper. So it's better that we all use the chart papers that are waste and not to use a new one. If we can get any used cardboard boxes or something like that, even those can be made use for this particular activity. All right. So once we roll out the cardboard paper, we can make use of the glue or the tape, whichever is convenient to you, and secure it tightly. And also, please ensure that the hole through which we view this, we make this tube, it should not be too large, because if that's the case, then you'll be viewing a larger part of the screen. So the smaller it is, the better the accuracy. But however, do not make it too small, so that it will be very difficult for you all to view through this scope, right? So now we are done with this tube. So what I'll do is I'll use this particular semicircle. I'll use a protractor to mark the angles. Now comes the tricky part. How do we mark the angles? Now I have a piece of semicircle here, a piece of cardboard cut into semicircle. So we have to place the protractor here at the center. All right. So wherever we have 90-degree, right here, that's the place we would mark it as 0. All right. So I'll tell you the reason in some time. So it's handy to have a marker or a sketch pen along with you. So as you all can see, I have marked this particular angle as 0. If this is how a protractor would look, you will have 0 somewhere here, and 0 from 0 it will climb to 90 and all the way up to 180, right? But here I'm marking 0 exactly at the point where 90-degree would have come, right? So now I would tilt my protractor, and what I would do is I would go in this direction. I will mark 10, 20, all the way up to 90, such that 90 comes at this edge, all right? So this is for us to mark. And the same goes on the other side. I have marked half of the cardboard here. So the same has to be replicated on the other side. You have 0 here at the center. On either side, we go from 0 all the way up to 90-degree. So our inclinometers measurement protractor is ready, all right? So now what I'll do is, I have a piece of thread to which I have tied an old pen. So the reason I'm tying this old pen is for us to find out the local direction of gravity. So when we hang away from a thread, what it does is it points towards the direction of gravitational force. So with this, we will not be in any kind of dilemma as to whether the place that I'm standing, whether that's horizontal or not. Usually it so happens that even though we are standing on an inclined plane, sometimes we happen to think that it is a flat plane and we take it as the measurement for horizon, right? So in order to avoid such discrepancies, we have a weight tied to the thread in order for us to find the angle. What we will do is, we will place the thread such that this thread passes right through 0, okay? So we will be tying this thread at the center here. So I'll use some tape to keep it secure in the spot. And also you don't have to use a very heavy object. Any object that can suspend the string down towards the direction of gravity would be more than sufficient, right? Okay. Now, as you can see, we are done with the suspension part. So I have to add the scope here along with the measuring protractor scale. So for this, I'll be making use of tape again. make sure that the finder scope in your clinometer is secure and is typed fixed properly to your measurement scale, right? So now with that, we have a inclinometer ready, and do not glue it all the way up to this point. Make sure that whatever sticking tape that you apply or the glue that you apply to secure the thread is only to this point, so that it does not affect the pivoting point of this thread. All right. So as in when we look through the sky, what happens is that we form an angle with respect to the horizon. Correct. I tilt this finder scope at some angle. The same angle will be reflected, would be read through all these points. Okay, if I tilt it all the way up to 90 degree, that is to the zenith, when I am looking at an object right above my head, this clinometer would give me a reading of 90 degree. Okay, so this is the first step. This is the first instrument that we'll be making object. So going on with the next slide, Nikita, may we have the next slide, please? Okay. So here I have another piece of cardboard. This again is simple. All right. So what we have to do is we have to have a full circle. Okay. So what we have to do, for the reason why we want this is, while we are measuring the angle, we also want to know the direction in which we are taking this angle of elevation. Correct. So in order for us to be able to do that, we need we can either use a compass to measure the angle. If we do not have a compass, the best thing is to use something like this cardboard direction indicator. So what we have to do is we have to take a cardboard and cut out a circle of nearly diameter of 60 centimeter. A cardboard of this size would be more than sufficient for us to do. Okay, so once we have a large circle cut out of this, we have to mark the angle starting from 0 and going clockwise all the way up to 360 degree. And once we are done making this, we will be placing it on the ground while we are taking measurement, such that the direction in which we have 0 degree points right to the north. Okay, so then while we are taking the measurement from the clinometer, we will be standing on this particular cardboard at the center. So as in when we are trying to locate an object, we'll be rotating about this center point, the pivot point, and we will know the angle by which we would have rotated with respect to the north. That would be indicated by the angle that is marked here on the cardboard, correct? So once we find the particular direction, that is, let's say I have a star here and this is my north direction, what I do is I rotate horizontally by some azimuth angle. Then I use my clinometer to measure the angle of elevation. All right. Once we have all these data, now we are all good to go with the star chart activity. So let's advance to the next slide. May we have the next slide, please? Great. So there are two ways in which we can mark the star reading that we take from the sky on a graph. Okay. One way is to plot it on a linear XY graph. So we have X and Y axis perpendicular to each other. We can have azimuth angles varying from 0 degree all the way up to 360 degree marked on the X axis. Then we have angle of elevation marked from 0 degree all the way up to 90 degree on the Y axis. So whenever we locate a particular star in the sky, there will be two readings. One will be the angle of azimuth, the other will be the angle of elevation. It is also essential for us to note down the time at which we start this particular activity and also the date on which we do this particular activity. So while we are graphing this, please make sure that whoever does this particular activity writes the date and time at which they start this particular activity. The reason is that we have the stars in the sky, they shift by an angle of 1 degree every 4 minutes. So that's approximately 15 degree shift for every 1 hour. So in order to make sure that all the markings that we do here on this particular chart is very accurate, is as much precise as possible, it is better to take all the readings within 5 to 10 minutes. By this time, we'll be able to easily accumulate the readings of close to 10 to 12 stars at least. All right. So you would need one person to locate the star and find the angles, and another person to note it down. And when we have all like 12 to 15 stars locations being noted down, then it can be easily plotted on the graph without errors. But if the activity continues for more than that, then we might have to take into account the error, relative error it would contribute for. Another thing that could be done to overcome this particular limitation is you can come back the same time the next day. Okay, the difference, the shift, apparent shift in the star would be very little with respect to the star chart that we are mapping right now. So that error would be very minimal. So we can start again at the same time next day. So there wouldn't be a very great shift with respect to the relative position of the stars as measured by this activity to ensure that. Okay, so let's say I find I'm finding a star at exactly in the south direction, and it is at an angle of elevation of 70 degree. The way to mark it here on the graph is we locate a point 180 degree along the x-axis, then we move up along the y-axis by 70 degrees. So here we have our stars. So we keep the information of all the stars that we will be taking that particular day, and we'll be marking it here like so. If you know the name of the names of those stars, you can also make a note of it. And it is also a better practice to mark the points in the numbers as in the order which they are taken in the reading. So let's say I take the reading of a particular star at the first reading. So I mark that point as 1. If I take the reading of another star as my second reading, I mark that star as second in this particular star chart. So it tells me that a star that is being measured the last would have more error with respect to the time that I have started, because it would have moved by some time, right? So in order to make sure that this data makes more sense to people who are trying to get more accurate relative positions, this is a good practice to start with. Let's advance to the next slide. We have a second method to plot this particular star chart, and this is more or less the way all the star charts would look like. Correct? We usually have the star charts being charted on a dome in a circular fashion. So this is more or less, it reflects that particular part. So we have an outer circle, which forms our horizon, okay, which forms the local horizon, and we mark this outer circle with angles starting from 0 all the way up till 360 degree. Okay, so then we start drawing concentric circles with decreasing radius inside this particular larger circle, such that it depends upon how many accurate markings you want. You can have close to 10 concentric circles, or you can have 20 concentric circles. If we have 20 concentric circles here, so we would, if we have 18 concentric circles here, each concentric circle would shift with another concentric circle by a degree of 5 degrees. Okay, so right now I have 6 concentric circles here. So the outer circle marks 0 degree. So the first inner circle would be 15 degree. So how do I get this particular measurement? We know that the total elevation, angle of elevation would be 90 degree, right? So if I look right above my head, that point forms zenith. So it does not matter if I measure it from east, west, north, or south. The angle of elevation for an object at zenith will always remain constant, which is 90 degree. Correct? So even if I approach it from west direction or east direction, this 90 degree would remain at the same position. Correct? So it would not change much. So our total, so whatever radius that we are considering for the outer circle will be attributed to 90 degree. So if I have 18 centimeter as my radius, so if I divide 90 by 18, okay, each centimeter would correspond to a shift in 5 degrees. So let's say this radius is 18 centimeters. Uh, right now, let's say this radius is 18 centimeters. So if I have another circle, concentric circle constructed at 17 centimeter, okay, so it would have shifted from the horizon by a degree of 5 degrees, okay. So right now I have 6 concentric circles here, which means that each concentric circle would differ by 15 degrees. So 90 divided by 6 would be 15, right? So first concentric circle will be 0, next concentric circle will be 15, the third would be 30, the fourth would be 45, and so on. We have moved all the way till 90. So if I locate an object exactly in the southeast direction at 60-degree angle of elevation, the point where I would be marking it is it would be 135 degree with respect to azimuth, because east would be 90 degree and south would be 180 and southeast would be somewhere in between, which is 135 degree. So from 135 degree, I'll go all the way inward to the circle where I have 60 degree being shown. Okay. So at that particular point, I'll be marking my constellation, or I'll be marking my stars reading. Okay. This way we will have all the stars reading being plotted on this particular chart. So this will more or less look like the normal chart that we would get online, right? So with that, we come to the end of the session. So now I request Nikita to take over for the stellarium. Nikita, maybe have you for presenting the session on stellarium?
Thank you so much, Tejas, for that, very short but so important and wonderful thing that all our teachers can do, as well as make students do, and the whole community. In fact, if there are any parents out there watching this, it is so wonderful that even you can do and you can make your children also do this, right? So now going forward, let us also explore stellarium. I will like take a quick I would take you all for a quick journey, I can say. So there is this stellarium application as well as a web. You can use it on web. So for now I would just show it to you all on web, so that you all can easily find it. And after this we have amazing session which will help you to understand what other activities you can encourage your students to do. All right, so let me open. So it's called as stellarium web. All right, and stellariumweb.org, this is what exactly you need to look for. I'm sharing my screen again. um, yeah, okay. I'm pretty sure all of you can see the screen. Tejas, if you can confirm me.
Oh yes, Nikita, the screen is visible.
Perfect. So this is called Stellarium Web. All right. You can look for it, and this is how it looks as soon as you open. Uh, and you can see there's already north, which means it shows all the direction. You can see north, west, south, and east. You might think, okay, is this the only thing which we can see? No, the answer is you can see the whole sky like this. Okay, you just need to operate it. All right, I would prefer not this, but yeah, this one. All right, so we can see the directions here: north, south, east, and west, right? And you can here see that moon is visible, Jupiter is in there. Also, there was Saturn. Okay, yeah, there is Saturn out there, and then there's Uranus, but we can't see through naked eye. These are a few other stars which are like bright stars out there. And one thing that you can do here is you all can see a tab which looks like date and time here, right? So this will help us to see what the sky would look like even after many days or like years, right? For example, here you can go and select which day. Okay, now today it's October 14, 2021. Like, let's say you want to see how the sky would be exactly 1 year later. Okay, that's basically 22. All right, I just changed it to 2022, and the time is still the same. If I want, I can also change my time. Like you can change the hours. I made it. Uh, I made it 6 p.m. 6 p.m. right now, and I will close it. So this is the exact sky which would appear next year on the same day. You can see that moon would have gone. Moon would be almost. No, moon is rising. Right, it is in the east, so you can see its moon is rising, and then you'll have Jupiter and Saturn. You can also see part of our galaxy. You can see the galaxy weave here, right? So this is one of the best thing that you can use to see when how the sky would look like. Most of the time, we use the stellarium to decide which is the right day to do a stargazing as well, right? For example, I will come back to 2021, and I would want to see when is that right day where I can see moon, Jupiter, Saturn, probably Mars, right? What I do is I'll just keep changing the dates, like 14, 15, 16th, like you can see here. This day, Moon and Jupiter is coming very close. But if you go farther and you can see all three are in line, I would be like, okay, this day is really nice because I have all three in line. And the time somewhere it starts around 6 o'clock. And how long will this pattern be there in the sky? Six, it's seven, it's eight, it's 9. Saturn is almost going to set. Till 10, we can see Jupiter and Moon, right? And you can see one something that happened here, right? You can see Jupiter and Moon. Like till 11 o'clock, you can still see the moon, and then they're all gone. After midnight, you can see how bright the sky was because of moon. Now, as soon as the moon sets, gets little darker. And these are the other, stars out there, and you can find. And as soon as it's morning, you can also see there is Mercury written, which means you can see Mercury in the morning. But then, as soon as when the sun comes, you can't see any stars. We all know that, right? So there's also Venus, if you can see, it's just behind the sun. So we won't be able to see Venus in the night because it's coming in the morning. But if it gets like as soon as the sun sets, you can keep seeing. But first of all, I would like to show one more important thing. Okay, fine, we're checking all these, but the place where you're seeing is very important, right? Like from where you're seeing, as I said, the point of observation becomes very important. For example, here you can see it says unknown because I haven't put any location right now. So you can use this location, like wherever you are, it'll track the location and it will show you the accurate results. All right. It is still showing unknown. So I would manually search for my place then. Or you can turn on auto location, like I just turned on auto location. If I turn on auto location and then click on use this location, I should be able to get my place. Did I get my place? No. Okay. You can actually download Stellarium app, which is easy to use it on your laptops. Okay. So, anyways, I'm going to search for Bangalore. So I'm going to select this, and then so you can see this location. If I want, I can actually change it to any location. For example, let's put Dubai. Okay. Oh no, I haven't selected. Okay, so Dubai, and search for it. Okay, so Dubai, I'm gonna select yeah, this particular location and use this location. So this is a sky which they would be seeing on this particular day at this particular time. Like let's come back to today. That is 14th of October at Yeah, it's around 7:11. You might feel like, okay, why is it bright there? The reason is the time difference, all right, and sometimes in the northern region it actually gets darker a little late. Like you can see, it gets darker eventually here in this 1 hour, I think, because the sun is already set. Yeah, you can see now it's getting darker, right? So this is how you can see Jupiter. Okay, you can see that from Dubai, we can see the Venus, but we weren't able to see it here from India, right? So there are a few things which you can see here and there, all right? Now coming back, what other things you can do is you can also observe some constellations. If you want just the shapes, you can find it like this, or you want to look at the stars and you can use like this, right? This is, as I said, this is one of the beautiful uh, tool to play through and observe the sky, right? Like for example, okay, now look at this. um, that is Venus. If I click on Venus, it will give us more information about Venus. How far is it, how big is it, where is its location. You can select moon, or like you can select any star, any constellations. You can find it, like you see I selected this star, and it gives every single details about this so and so star. So this event can actually be conducted online or offline. Offline is when you have all the students with you. You can just open up this app and show them, see them, and you can ask them, okay, find how the sky would be on your birthday, and they would be very excited. If it is an online event, you can still do the same thing, like just like how I did. You can just screen share and ask them to see, explore, probably take a screenshot of what they would see on certain day, and probably allocate them. Okay, you know what, let's do one project. Select certain day, select certain date and a time, and ask few students, okay, you see from this country, you see how it would be visible from this country, right? And take a screenshot, or everyone can do the same thing and they can make a chart, and then we can understand how the sky would differ when we see from place to place at the same time, right? This is wonderful experiment that we all can do, and you can ask your students to do. So that's what I wanted to explain about stellarium, and now I would leave it to Tejas.
Thank you so much, Nikita, for that wonderful explanation. And also, while you are on the screen, I would also like to make the announcement for the Teachers Outreach Program competition. So we have two set of activities that we have for all the teachers. As you have gone through this particular outreach program, training sessions, and the workshops, we would also want you to take it all the way to your students. Correct? That is the main aim of this particular program. In order to make that happen, what we'll be doing is we'll be sending today's workshop material, the presentation, as well as few instruction as to how to conduct this particular session within your school and community. And once you execute this in your school, you can share those videos, photographs, and a small report about the event that you have conducted, hosted in your school, and send that to outreach@sserd.org. We will be awarding you a certificate as a partner of SSERD in outreach program. All right. So here is your chance to partner with us for reaching out to more and more students and more, larger community in order to take space education all the way to the roots. So along with that, the competition that we had for teachers outreach program is the main aim of this particular program was to innovate in teaching techniques, correct? So after all these programs, we want to know what are the innovative ideas that you all have for making teaching more interesting, correct? So we want you to make a small report or a PDF, a presentation wherein you outline the activity or the event that you would plan to conduct for your students in making teaching more interesting, whether it's making use of a particular toy or an idea to create a particular toy, or having the session wherein it is very different from the normal sessions. So something very innovative. So you can present all of these things in any of the formats. All you have to do is you have to send us the work that you have done through the email at ss or to outreach at sserd.org. We will share the details of this program to the registered emails for the participants. And also, if you have not registered yet, so please go and register. You have a 2 days time, that is 15th and 16th. In these 2 days, we want you to prepare this report and send it to us by 17th morning. That is 10 o'clock when the deadline for this particular competition closes. So we'll be selecting one particular idea or one particular project, which is most innovative amongst all of the projects or the themes that has been submitted, and we'll be giving that particular teacher or an educator an award. All right, so this is a community event. This is where educators help educators to innovate. So I request you all to take part in this particular competition. And as promised, we also have a session right now wherein we'll be talking about the opportunities and career path that could be explored in STEAM, so that teachers can use this as a reference material to guide their students to engage themselves in STEAM. So with that, Nikita, I take your permission to invite Karthik on screen. Okay, hi Karthik. So we have Karthik here with us from SSERD team who will be telling us more about the opportunities that are out there which teachers can use to guide the students to engage in STEAM.
Thank you, Tejas. I welcome all of you for the outreach program. Now I have to share this screen. So we will discuss about the opportunities and academic part in the STEAM. So what this means? This stands for the science, technology, engineering, art, and the mathematics. We will discuss about the opportunities which will include the scholarships, award and fellowships, examinations and Olympiads, contests, and the career opportunities. So let's discuss about the scholarships and awards. So first one is the Kishore Vaigyanik Protsahan Yojana. It is the program from the government to encourage students for the studying in basic science and to take up the research career in the science. It will provide a fellowship up to the pre-PhD level or 5 years, whichever is earlier. Also, it provides a platform to get a summer camp for the KVPY fellows who get selected in this program in the best research and educational institute in our country. So there are three streams here, and there are various eligibility criteria for these streams. The first stream is the STEAM essay. It is for the students who have passed the 10th and eligible to appear in 12th. The fellowship of the students selected under this stream will be activated if they join the basic science undergraduate course with 60% and above marks in the 12th examination. And the STEAM SS is the student for the which is enrolled in the 12th standard and want to pursue the undergraduate course in basic science. The fellowship criteria is same for all the streams. The STEAM B is the SB is the for the students who have passed the 12th and eligible to enroll in undergraduate course in basic science. So these are the important dates. The date of application is between July and September month, and the date of admit card issue is in October month. The exam date is in the November month. The date will be arranged according to the occasions. So we can find out more about this in this website link. And the exam mode is the computer-based online. It is beneficial to get admission to the prestigious institute to make a strong CV and the research experience and the future career opportunities. Next one is the INSPIRE, that is Innovative in Science Pursuit for Inspired Research. It is the program by Department of Science and Technology, DST, and it provides a budget every year for the students who want and expanding the science and technology system in our country. It has a two program. First one is the scheme for early attraction of talent, which aims to attract talented students to study the science and providing Inspire Award of rupees 5,000 to 1 million students in the age group of 10 to 15 years. And it arranged the summer camp for about 50,000 science students of class 9 with the global leaders. And there is a scholarship for higher education which aims to enhance the rate of attachment of talented students to undertake the higher education in the science field by providing the scholarship of rupees 80,000 per year. So this scheme is for the age group of 17 to 22 for undertaking the bachelor's and master's level education in the basic science, and it is eligible after the 12th examination. So this is the two programs in the scheme for early attraction of talent, that is SEED. First one is the Inspire Award. The school students from the 6th to 10th are being identified for the Inspire Award, and each Inspire Award envisions an investment of rupees 5,000 per children. The eligibility criteria is that the award is for only 6 to 10 class student, and there is no examination in for qualifying in this Inspire Award. The student name is nominated by the principal, and each student get the 5,000 rupees for making the project, and transportation cost is displayed. Uh, Transportation cost is provided by this program for displaying the science projects in district, state, religion, and national level exhibitions. And for the Inspire internship, they provide a summer camp for about 50,000 science students. And and to eligible in this program, we have the student must have to top 1% ranking in their 10th board examination, and they must be pursuing science in standard 11. Next, the eligibility criteria for the scholarship for higher education, it must be in the top 1% in the 12th board examination. And the student who have early proved their credential in the KVPY, some international Olympiad, some national talent search examination, is eligible for this scholarship. And those students who have secured the JEE or NET ranks in within the 10,000 ranks is also eligible for this program. And it must have considered the undergraduate course in the basic science, that is BSc, BS, or integrated MSc and MS course to eligible for this scholarship program. And the age bracket is 17 to 22 years. The online application released in the first week of the November, and it closed in the last week of the December. And the result and cutoff release date is in the last week of the June. After selection, each student will be provided with rupees 80,000 per annum. And this is divided into two parts. The 60,000 rupees is the annual scholarship, and the summertime attachment fees of rupees 20,000 to do a research work in the undergraduate course. The scholarship is provided for a maximum of 5 years and until the completion of course. In that, they regularly check our progress in the undergraduate course and request a mark sheet of our undergraduate semester exams for regular check of our performance and providing them scholarship. Okay, next one is the Science Academy Summer Research Fellowship Program. It is organized by the three national science academies, and one of the science academy is in the Bangalore itself. So it is to work, this program provides opportunity for the student to work with the eminent scientists in a prestigious institutes. So applicants must be in a BSc, which is in the, it must be in the second year, and it must be in a dual degree of BE plus MSc and BS plus MS, and it must be in a second, third, and fourth year. The application released in the week of October and it closed in the last week of November. The selection result date is released in the month of March. The additional criteria for this program is that it will it will record it will consider the score of course score from the 10th to the first year of undergraduate course, and it must be about 60%, and it must be there must be a letter of recommendation from the two professors and a motivation letter which will explain about your aim and objective in the science field. Okay, so let's talk about the Olympiads and the competition. First one is the International Olympiad in Astronomy and Astrophysics, that is IOAA, which is organized by Homi Bhabha Center for Science and Education in India, and it is the international Olympiad which is organized up to the 22 countries. So the eligibility criteria follows the 5 stages. First one, we have to first qualify the National Science Examination in Astronomy, that is NSEA, and the eligibility for this exam is the Indian student which are in the class 12 or lower. And after qualifying this, there is a Indian National Astronomy Olympiad INAO, and after that there is a orientation cum selection camp. There will be a pre-departure training camp, and then there will be a IOAA. The selected student in the pre-departure training will represent the International Physics Olympiad on the international level. So it comes with the subject of astronomy, mathematics and physics, chemistry, junior science and the biology. The date of application is in the September and October month, and exam date is in the January month. The eligibility criteria for the junior science, it must be an Indian citizen, it must be studying in class 8 and 10, and the date of birth is must be in between 2007 and 2008. Same for the eligibility criteria for other subject. It must be an Indian citizen, must be studying in class 8 to 12, and date of birth between 2002 and 2007. So this is the scheme that I have explained. Next one is the International Space Olympiad, which is organized by EduMidra, and each year with the mission to excite and encourage talent in the field of space science, it is organized at the international level. Students studying in grade 5 to 12 all over the world can participate in this Olympiad. It has 3 levels: the preliminary, intermediate, and the final. The candidates have to qualify the first round to get into the second round, and vice versa. The categories are the junior categories for the grade 5 to 7, senior categories for the grade 8 to 10, and super senior category for the grades 1 to 12 students. To participate, we have to register using this website. Next one is the International Astronomy and Astrophysics Competition. This is the very new competition in the field of astronomy, which provides an opportunity to prove your skill and unleash the creativity in the field of astronomy and astrophysics. It provides challenging problems and some questions which can be solved by using your skills. And participant can receive the certificates, award, cash prize, and global recognition. Age categories are divided into two: juniors, which will be below 18, and senior, which will be above 18. There are 3 rounds. First round is the qualification round, which will have 5 astronomy problem, and it is subjective. That is, we have to use the calculator and we have to solve these problems. Then after qualifying this round, there will be a pre-final round, and after it will have 10 astronomy problems, and there will be a final round with 30 MCQs. So this is the very exciting program held every year. There will be a National Astronomy and Science Olympiad, NASO. It is joint venture of NAVAS Educate and NASO Educational Society to develop ideas among the youngful age Olympiads, and it gives an opportunity for the winners to explore the NASA Kennedy Space Center and ISRO Space Centers. So there are 2 rounds. The level 1 is for the school round, and level 2 is the national round. The eligibility criteria is that students studying in the grade 2 to 10 in ICSC, CBSE, or any state board are eligible. How to apply? The school are requested to send the registration form with the participation fees to the program organization. An application deadline for this is October month. Exam center will be organized in your school. So the next one is the most famous Olympiad exam, that is National Science Olympiad and the International Mathematics Olympiad, which is organized by the Science Olympiad Foundation. It is open to the student of class 1 to 12, and the prospectus containing the registration form are sent to all school which is registered with the SOF. So any school which is not registered with the SOF will not get any notification from this organization. So the exam will conducted in the same school for the level 1, and after qualifying of some student for the level 2, it must be organized at some other center, and no fees is required for the institution to become a registered examination center. Same thing is for the International Mathematics Olympiad, which is open for the student of class 1 to 12. So there is the International Earth Science Olympiad for the students who are very interested for studying the earth science. So it will come in the 4 stages: the national level entrance stage, training camp, and the Indian National Earth Science Olympiad, the pre-departure training camp, and the participation in the International Earth Science Olympiad finally after completing the 3 stages. The eligibility criteria is that the students who are Indian are the only eligible. The students should not be older than 18 years, and the students who are studying in the 9th, 10th, and 11th are eligible to apply. The application start from the September month and ends in November month, and the date of examination is in the December month. So let's talk about some contests. So there is a world famous contest, that is Space Settlement Contest, which is organized by the National Space Society and NASA AMIS. So this is the space art competition for the students up to the 12th grade from anywhere in the world. It will be in an individual form, small teams of 2 to 5, and a large team of 6 to 12, and they are judges separately. And no more than 12 students will be in a single project. So date of entry is in the month of December and deadline is in the February month. You can find out more about this space settlement in this website. So the next challenge is the next contest is the Caltech Space Challenge. It brings the 32 talent and highly motivated student to Caltech to participate in a week-long space mission design competition. It must be a full-time undergraduate and graduate student of any nationality, and it must finish their undergraduate degree before applying for this contest. So the application deadline is of November 1, and it requires the letter of recommendation from the 2 professors, and the deadline for that is November 15. The competition date is in between March 21 to 25, and it targets the audience of undergraduate and graduate students. And it requires the additional requirement of CV, resume, letter of recommendation, and motivation letter. So next one is the Intel's International Science and Engineering Fair. This is organized by the Society for Science and the Public, and it is the world largest international pre-college science competition. For process of participation, we have to conduct your own scientific research project and submit them to affiliate science fair at the local, region, or state level exhibition to earn a spot as a finalist in the international competition. There are some career opportunities in this science, technology, educational. Okay, so after 12th, for undergraduation and integrated degree, there are some entrance exams, just like the JEE mains and advanced, BITSAT, and the NEST. So JEE mains and advanced are the entrance exam for the admission in the IITs, NITs, and other prestigious engineering colleges. The eligibility must be the students should have passed the 12th class with 75% marks in aggregate, and it must qualify the main examination, and then it must qualify the advanced to get admission in the IITs and NITs. Application opens at November and application close at December. The exam conducts mainly in the February month. BITSAT is the entrance exam for the admission in the Birla Institute of Technology, and the eligibility is same just at the main JEE mains and advanced. And and the next is the engineering and science entrance exam for the admission in the NICER and the ICER institutes. After undergraduation, for pursuing the masters in science and the engineering, there are some competitive exams such like the GATE. So it is the engineering exam for admission in the IITs, NITs, and other engineering colleges, and it requires an eligibility of a bachelor's degree in the engineering and in the BSc. So for the GEST, it is the science entrance exam for the admission in the IIA, IISc, IUCA, and other prestigious institute. Eligibility is same for the GATE and the IIT exam. That is, it requires the undergraduate degree in the engineering technology as well as in science or in science. And IIT exam is the entrance exam for admission in IITs and NITs specially, and it requires the same eligibility criteria. So, if you want to make career in the astronomy and astrophysics, let me tell you that there is no university in India which offers undergraduate program in astronomy. That is a degree course after the 12th. So, at the master's and PhD level, there are several options. You have to get an BSc in physics or engineering subject after 12th and apply for the master's degree program in one of the Indian institutes, that is Indian Institute of Astrophysics, Indian Institute of Science, Raman Research Institute, IUCA, NCRA, etc. So there is if you want to apply for the entrance exam to study abroad, so there are record examination, that is GRE, which is conducted by ETS, and it is one of the world largest assessment program for graduate admission in business or law school or any science school in the USA. So there is no prescribed age limit or qualification required for the candidate to apply for GRE, but it requires graduate course. It requires an undergraduate program for the students. So there are basically two types of GRE. First one is the GRE general test. It takes into account the verbal reasoning, qualitative, quantitative ability, and analytical writing skill. And subject test will focus on the mathematics, literature, physics, psychology, biology, chemistry, and biochemistry. The exam date based, the GRE computer based format of the test happens every month. So if there is a 45-day gap in the university admission process, then you can give GRE. So you can find out more about this in this website. There is the socialistic assessment test, that is SAT, which is a standardized test administered by the college board, and it's required to be taken by the students seeking admission to the undergraduate school. So if you want to study abroad after the 12th, you have to prepare for the SAT exam. And applicants who aspire to pursue undergraduate course, particularly in the US and Canada, are required to qualify this SAT examination. Eligibility criteria: there is no minimum or maximum age limit set by the conducting body, but students are required to have successfully passed the high school exam, that is the 12th examination for admission in undergraduate studies. So it comes with the two type. The SAT exam test knowledge, knowledge of reading, writing, and maths in first paper, and the second paper focus on the English, history, mathematics, science, and the foreign language. You can find out more about this examination using this website. An application deadline is 1 month before the date of examination. So thank you so much for joining today and giving your valuable time for attending this workshop.
Thank you so much, Karthik, for that elaborate briefing of all the opportunities that were available in STEAM for teachers to guide their students. So I bid you adieu from the screen right now. So with that, we have come to the end point of this particular workshop, today's workshop, and also the last point of all the training sessions that we had planned for the Outreach Teachers Program. So without further ado, let me remind you all regarding the competition that has been rolled out today. So gear up and plan some innovative activities for all your teachers, all your students, and outline the framework and do share it with us. And also we have the closing ceremony being organized on 17th, so do join us there. So this is Tejas, your host, signing off for today.